Okay, so now we're going to come on then to look at the answers to those questions, which hopefully you've had a go at. Question 1, okay, is Herbert Simon, okay, suggested that people make decisions in different ways. Maximizers are people who engage in excessive searching when coming to a decision, whereas satisficers are those who settle for a good enough solution. So there are differences in the ways in which people make decisions, okay, between being maximizers or between being satisficers. And Yang and Chu 2010 presented maximizers and satisficers with different types of choices. Half were presented with a broad choice set and half with a narrow choice set. Similarly, half of the satisficers were presented with a broad choice set and half with a narrow choice set. And they predicted that maximizers would make better choices and more choices when presented with a narrow choice set, and satisficers would make better choices and more choices when presented with a wide choice set. And they recorded quality of choice and the number of choices, and the results are shown in your table 1. You need to use an appropriate statistical technique to analyze the data and say whether the prediction of Yang and Chu is supported. Okay, so this is a two-way between participants design then. So we've got the type of decision maker, okay, whether they be a maximizer or a satisficer, and within each of those types of decision maker, half were presented with a broad choice set and half with a narrow choice set, okay, and the researchers recorded 2 DVs, so it's a multivariate test, which is quality of choice and number of choices. So we've got the type of decision maker in our SPSS table represented by numbers 1 and 2, and the type of choice set with which they are presented, which is represented by numbers 1 and 2. Okay, and they recorded 2 things, quality of choice and number of choices, represented in columns 3 and 4 there, okay, as the 2 dependent variables. If you look first of all at the descriptive statistics, you can see in the top part of the table we've recorded it's shown us the means for the quality of choices, and the bottom part of the table the means for the number of choices. And then you can see maximizers, broad choice set, maximizers, narrow choice set, satisficers, broad choice set, satisficers, narrow choice set. Looking, for example, at the quality of choice, so you can see that for the maximizers already in the broad choice set, you've got a score of 3.7, and in the narrow choice set, a score of 6.7. Okay, and if you look at the plot as well, you can see that we've got looks like some kind of interaction effect going on there, with maximizers making a better quality of choice in the narrow choice set when presented with a narrow choice set, and satisficers making a better quality of choice when presented with a broad choice set. Okay, for the number of choices, it looks like those presented with a broad choice set are making more choices than those presented with a narrow choice set, but we obviously need to look at that effect in the ANOVA calculation. So if we look at our between subjects effects table, or between participants effects table, if you go down, scroll down to the 3rd row there where it says type, it's telling you the type of decision maker, okay, and the effect for quality of choice and number of choices. So you can see that for quality we've got an F score of 1.48 and the significance level of 0.23, which is not below our criteria of 0.05. In fact, the only one is for the type of choice set presented for quality, okay, where we've got an F score of 3.3 and a significance level of 0.07, which is not significant, but it's kind of getting close to the 0.05 level. The only significant effect here we have is the interaction between type and choice for quality of choices, where we have an F score of 101.30 and a significance level of 0.00, so that is significant, as I showed you in that interaction table going back there a few minutes ago. So what do we find then? So we carried out a 2 times 2 between participants multivariate analysis of variance, which revealed no significant main effect for decision making type or for quality or number. No significant effect was observed for breadth of choice, okay, in terms of the the choice set with which people were presented, okay, for quality or number. Okay, there was a significant interaction observed for quality, okay, and the F is for 1 and 32 degrees of freedom, 1 and 1.3, okay, and is significant at 0.001. And you need to add to that to say which way around or what that result is telling us. Maximizes making better choices in the narrow condition, satisfies us making better choices in the broad choice set condition. And I should add onto that as well that there was no significant interaction, was there, for number of choices. So the other DV you ought to mention underneath that as well, no significant interaction for that. Question 2 then. Psychologists wanted to investigate how people would choose to go on a date. They presented male and female participants with faces and instructed them to respond by pressing a button to indicate yes, they would go on a date, or no, they would not go on a date with the person in the photograph. Psychologists were interested in the time it took participants to respond to each of the 3 different types of faces. And the 3 types of faces they used were unattractive, averagely attractive, or attractive. Because they thought that the participants' level of impulsivity might affect the results, they also recorded this as a covariate. And the results are in your table 2, which outline response times, okay, for groups of males and females for the 3 types of faces presented to them, along with their impulsivity scores. And you to use an appropriate statistical method to analyze the results and interpret the findings. Okay, so it's a two-way mixed design. The between participants factor is gender, because you can't be both male and female, so they presented either males or females, and everyone was presented with the 3 types of faces, the unattractive, the averagely attractive, or the attractive faces. In columns 2, 3 and 4, you can see the response times, okay, that it took males and females to respond to each of those faces. And in the 5th column, we can see their impulsivity scores. Okay, so they're recording impulsivity as a covariate in this case, because they're thinking, well, response times might also be affected by impulsivity scores. So if you run that correctly, you should have a descriptives table which looks something like this. Okay, so first of all, if we look at that, we've got the mean response times for the unattractive, averagely attractive, or the attractive faces. Okay, for genders 1 and 2, if we say that gender 1 is male, gender 2 is female. So for the unattractive faces, we've got gender 1 and 2, okay, and the mean response times in milliseconds there. And if we look at our plot, okay, we've got along the bottom there, we've got the level of attractiveness for the faces 1, 2 and 3, and the males represented by the blue line and the females by the green line. Okay, so you can see for the male response times, for example, okay, they're responding quicker to the unattractive faces, and then it kind of plateaus for the attractiveness levels 2 and 3. For the females, they're responding slower than the males, but they're responding slowly to the unattractive faces. The response timing slows down, sorry. They're responding quickest, I beg your pardon, aren't they, to the unattractive faces, similar to the males. Okay, even though it is slower. They're responding a little bit slower to the average attractive faces and slower still to the attractive ones. Okay. We need to look at a couple of tables here. So if we look firstly at our table of between subject effects, between participants effects, so for level of attractiveness, and we're using the severity assumed line at the moment, so we can see for level, okay, we've got an F score of 1.27 and a significance level of 0.29. So that one is not significant. So there's no significant effect for level of attractiveness. And if we combine that with if we go down to the level times gender, there we are. The interaction between level and gender, again for severity assumed, okay, we can see that we have an F score of 0.40, okay, and a significance level of 0.66. So there's no significant interaction between level and gender. And if you look at our between participants effects table, okay, we can see for gender, for example, we've got an F-score of 0 and a significance level of approaching 1 there. So really, there's no significant difference between males and females, even controlling for the impulsivity scores. Okay, the attractiveness levels, there was no significant effect there, but just for good measure, I've run the paired samples t-tests. If there was no effect there, you probably not normally run that post-hoc test, but I've just run that for good measure. So I'm comparing the unattractive against the average, unattractive against the attractive, and the average against the attractive. And as you can see in the final column there, okay, none of those significance levels are below 0.005, okay, and they're not below the Bonferroni corrected number either, so none of those comparisons are significant. So overall then, in running this 3.2 mixed design analysis of covariance, okay, there's no main effect for level of attractiveness. Okay, so there was no main effect in response times for level of attractiveness. And even controlling for impulsivity, there was no main effect for gender in terms of response times either. So in that little example, we found no significant effects whatsoever, which is quite often the case, but that's guess what we have to live with. Okay, hopefully you've done that correctly, and next time we'll be moving on now to look at how you might use these tests in your projects.